Hi, welcome everyone. Welcome back to my channel. Today we are doing similar figures. Well, before I start, I'm running Easter course for 15 days and starting from 7th of April. It's for all the three sciences and mathematics. We'll be trying to cover almost all syllabus within these days. So if you're looking for that, it's just you can say the complete course each day for each subject. You have to give your 1.5 hours and the total cost is £90. It's very discounted one, and if you will take 2 subjects or 3 subjects you can avail the further discounts. Okay, and also you can book individual classes for specific topics and each will cost you just £5. It's like I would say it's a great opportunity. And also I'm running GCSE batches and one-on-one classes, and me and my tutors provide classes from year 1 to year 13. And like if you need classes, you can just drop us an email at exactacademy@gmail.com and we can coordinate there. Okay, so just let me start with this topic. As you can see here, it's a 2D shape which is a triangle, and these two triangles looks similar. The only difference is in their size. Obviously, the green one is smaller as compared to this red one. So I would be saying that in terms of their shape, they are exactly the same. I can see like each angle, they are almost same, but their lengths are not same. So such figures are called similar figures, where all the corresponding angles are equal and the corresponding sides bears the same ratio, which means suppose if I'm saying this angle is 90 degrees, then this angle will also be 90 degrees. This angle is 30, then this angle will also be 30 because it's the corresponding angle. And if this angle is 60, this angle will also be 60. So when all the angles are same and the sides are in proportion, that means suppose this is 3 centimeters and this will be 9 centimeters. You can clearly see their ratio is 3. That means the red one, the bigger one, is 3 times the smaller one. Obviously they are not, but I'm just telling you, don't go by the diagram. And similarly, if I'll say 4, because I know that one length is 3 times, that means all corresponding lengths will be 3 times, so it will be 12. This is 5, so this is going to be 15. So this is how we can find the answer, and this is how we can know what are similar figures. It's not just confined to 2D figures, it's confined it's for the 3D objects as well. Similarity is same, that their shape is exactly the same, the corresponding angles are exactly the same, but their lengths are in proportion. So the first thing that we are going to study is length scale factor. So this is length scale factor. So length scale factor is that by which one object is that times the another object, which means simply I can say if I'm calculating the length scale factor, this will be length of one triangle or one figure over length of, or I would say corresponding length of another figure. So taking the example of these two triangles, if like our example was 3 centimeters, this was 9, this was 5, this was 15, this was 4, this was 12. So the length of one figure, let's say 5, and I'm writing 5 here, over corresponding length, that means this is hypotenuse, so I have to pick hypotenuse. I can't pick base in this case. So that's the meaning of corresponding side. So when I'm dividing the corresponding side, I'm getting 1 over 3, and it has to be in the same ratio, which means when I'm dividing 3 and 9, the corresponding figure, this will give me 1 over 3, and it goes with the last one as well. 4/12, which is 1/3. So they all are bearing the same ratio, hence they are similar figures. And this is called length scale factor. So in this case, 1/3 is going to be length scale factor. So I can say that the green triangle is 1/3 the red triangle. Now let me see one question and see how can we apply this concept. See this question. It says two similar triangles are given. Find the value of x. They have already mentioned that they are similar triangles, which means there are two things. First thing, that all the corresponding angles are equal. And second thing is corresponding sides are in ratio. So because there is no involvement of the angles here, only we have to look for the sides. We have to calculate the sides, so they should bear the same ratio, or I would be saying that the length scale factor would be same. So I can say 4 divided by 8 is equals to 5 divided by x. Remember, if in numerator you are using the sides of green triangle, so every time the sides of the green triangles will be in numerator and sides of red triangle will be in denominator. If you will do like a random thing, you will not get the correct answer. So then from here I can calculate the value x as 10 centimeters. And this is very obvious. We can see that one side is 4, another is 8. That means the red is twice of green. So every length will be twice. So if 5 is the length of the green, red will be twice of it, which is 10 centimeters. Moving on to the next question. This question says, in the figure given above, rectangle ABCD and GEBF. ABCD, this bigger rectangle, and GEBF, this smaller one. They are similar. Well, let me tell you one thing. All squares, I'm not talking about the rectangle, all squares are always the similar because they maintain the same shape. That means for all right angles, therefore all the angles are equal, and as well as all the four sides are equal as well, meaning the ratio of corresponding side is constant. And same goes with the circles. All circles are similar. Now coming back to this question, it says that in the figure given above, AG is equals to 6 centimeters. So let me just label it AG. AG, this part is 6. Only this part. EF, that means this one is 4 centimeters. BF, that means this one is 6 centimeters. Then we have to find the length of AD. First thing is, it's already mentioned that these two rectangles are similar. And if these two are similar, that means obviously we have to use that the corresponding sides are in ratio. So corresponding side AB. AB is the corresponding side. AB over GB. Because this side, this is the side, this is a whole rectangle. Don't just take this one because this is not a part of any rectangle. This whole AB is a part of a rectangle over GB. And GB is obviously, EF is given as 4. That means GB is 4 as well. As opposite sides in a rectangle are equal. So AB over GB is equals to BF. Because what we have to calculate the length of AD. Okay, so if I'm calculating the length of this one, this would be my corresponding side. BF is given as 6 centimeters, so applying the same thing, that opposite sides are equal of a rectangle, so this is also going to be 6 centimeters. That means I have to divide AD over GE is equals to AD over GE. We know this whole AB is 4 plus 6, which is 10, and this only GB is 4 over 4 is equals to AD, this whole length AD that we have to calculate, over GE, which is this, that is the 6 centimeters. And from here, I can calculate AD is equals to 10 into 6 over 4, which will give you answer as 15 centimeters. So AD is 15 centimeters. Moving on to part B, calculate the area of the shaded region. It's very clear. If I calculate the area of this whole rectangle and subtract the area of this only smaller rectangle, I'll get the area of the shaded region. So this was for part A. And for part B, area of shaded region is equals to obviously area of the bigger rectangle, which is ABCD, and area of smaller one, which is EFBG, or I would say GEFB. So I have to subtract the area of these. ABCD, your length is 10 and your 15. So another dimension, this is 15 that we have calculated. So I can say length is 15 and width is 10. So area of ABCD is 15 times 10 minus your length is 6 and width is 4. So area of this smaller one will be 6 times 4, which is 150 minus 24. That will give you answer as 126 centimeters squared, and this is basically the area of your shaded region. Now the next is the concept which deals with 3D figure. So let me see this one. This is a prism. They both are similar, which means clearly each of the corresponding angles are equal and their lengths are in ratio. So that makes this 3D figure. Same goes with the 2D and 3D. So that will make a 3D figure similar figure. But when we are talking about 3D figures, there are two other parameters that we have to talk about, is the area scale factor and the volume scale factor. Because when you are talking about a 3D figure, you are talking about the surface area, obviously. Obviously, the area scale factor is used for the 2D figure as well, because we calculate the area of a 2D figure as well. But if you can calculate the lengths, finding area is much more simpler. But you can apply the concept there as well. So here also, because finding surface area is a bit tougher, so obviously if you want to if the surface area of bigger one is K1 and you have to calculate the smaller one, so applying this concept is much more easier. That is the area scale factor and a volume scale factor. So I'm starting with the area scale factor. So area scale factor, just like the length scale factor, that means area of one figure or area of figure 1 over area of figure 2. So basically area scale factor is the ratio of areas of two corresponding figures. Just like the length scale factor is the ratio of lengths of corresponding figures, corresponding lengths of the figures. Similarly here, the area scale factor is the area of both the figures, the ratio of the areas of both the figures. There is one more formula. Let's say L be the length scale factor. Then area scale factor will be L squared. So there are basically two ways of calculating. Suppose if the areas of two figures are given, you can use this formula to calculate area scale factor. Or if you have length scale factor given and you want to know the area scale factor, you can use this one, which says area scale factor is L squared. Now the next one, which is a volume scale factor, is exactly same, which means formula is volume scale factor. Just like length scale factor is the ratio of lengths, volume scale factor is ratio of volume. Similarly, I would say the volume scale factor is the ratio of volume of the figures. So I can say volume of figure 1 over volume of figure 2. Just like area scale factor, there is one more formula for volume scale factor as well. Either you can apply this one if it suits with you or if it goes with your question. If it's not, you have to apply the second one, which is volume scale factor is, because we have assumed L to be length scale factor, then L squared is your area scale factor and L cubed will be your volume scale factor. So these three things are very important. You should know what's length scale factor, what's volume scale factor, what's area scale factor, as well as the condition of similarity, which says the corresponding angles should be equal and the size should be in same constant proportion. Now, let me solve the question number 3. The figures given above are similar. If the height of the bigger cylinder is 10 centimeters, the diameter is 6 and the height of the smaller is 5, then find the radius of the smaller cylinder. So we just have to label what's given. Height of the bigger cylinder, which is this, is given as 10, and diameter, we have to find the radius. So if diameter is 6, radius will be half of it, which is 3 centimeters. Then the height of the smaller is 5. This one is 5, and we have to calculate the radius. If these two are similar, it's easy. We just have to divide their ratio, corresponding sides, and find the ratio. So 10 over 5, obviously height of bigger over height of a smaller, that will give me 10 over 5 is equals to radius of the bigger over radius of the smaller. So radius of the bigger is 3, and let's say R be the radius of a smaller. So from here R will give you 1.5 centimeters. So answer is 1.5 centimeters. Next is ratio of surface area of smaller to the bigger. We already have the length scale factor. What's length scale factor? 10 over 5. So length scale factor is 10 over 5, which gives me 2. So area scale factor will be square of length scale factor, which is 4. Ratio of surface area of smaller to bigger. 4 is for bigger to smaller. So that means area of bigger to smaller is 4. So area of smaller to bigger will be reciprocal of it, which is 1 by 4. And that's your answer. Moving on to the next question. Question 4 says, in the figure given above, radius of the bigger sphere is 9 centimeters, which means this one. This bigger one is 9 centimeters. And the smaller one is 3. We have to calculate the volume scale factor. It's very easy. Let me find the length scale factor, which says divide the corresponding sides. That will give me 9 over 3. That is 3. Even if you will do 3 over 9, that's perfectly fine, because they haven't mentioned specifically that they want the ratio of bigger to smaller. Okay, so yeah, if they have specifically mentioned that the bigger sphere has transformed into smaller, then you have to find the length scale factor, or you have to find volume scale factor. That means in this case they are asking by which factor you have to multiply the bigger one so that it can be transformed into smaller. In that case, obviously you'll do 3 over 9, that is 1 over 3. So you have to multiply the bigger one by 1 by 3 so that it can be converted into the smaller circle or sphere, sorry. But here they have mentioned nothing. So we can take bigger over smaller, which is 9 over 3. That will give me 3 as a length scale factor. So volume scale factor is cube of length scale factor, which is 27. Moving on to our last question. In the figure given above, two prisms given are similar in shape. If volume of smaller prism is 135 centimeter cube, find the height of the bigger prism. So first thing is, they have already given the volume of smaller prism. What we can do, we can just calculate the height of the bigger one. That's easy. So I can say, as the volume of smaller is given as 135, I can calculate volume of the bigger one by using volume scale factor. Or there's another way. We can just calculate the corresponding side of this one. There are two ways. First calculate this one and then get this, or directly use the smaller one. Because we know they are similar, so I would be saying 12 over 6 is equals to 18 over, let's say this be x over x. From here, I can calculate this as 9 centimeters. So I'll get to know this is 9 centimeters. Now we have to calculate the height of this, which is this one. Only look out this smaller one, right? See, same thing I'm saying, that either you can start with finding this one directly and you have to multiply the 135 with volume scale factor and then find this height, or we can find height from here and multiply the length scale factor to it and get the height. Both will work. Because volume of smaller is given, so let me start with this one. Half times base, which is 6, times height, let's say h be the height, times length, which is 9, is equals to 135. From here we can easily calculate the value of h, which is 5 centimeters. So height of smaller is 5 centimeters and we know the length scale factor is 2. You can clearly see, which means the bigger one is twice of the smaller one. So if this is 5, this is clearly the twice of which is 10 centimeters. And in this way we can calculate the height of the bigger prism. So that's it for today. If you want to get this worksheet for free, this written material, it's in a printed form, like in a digital form, that's available on our website, which is exacademy.com, and it's available for free. You can go there and download, as well as the worksheets are also there. You can download, practice, and also the answers are available. You can check your answers. And if you are looking for one-on-one classes, or if you're looking for test series, we are running the test series as well. So for all that, whether for one-on-one classes, group classes, Easter classes, classes from year 1 to 13, for free worksheets, for paid worksheets, or you can say paid papers, model papers, specimen papers for 11 plus, for GCSEs, for 8. To avail all this, all you need to do is just email us at exacademy@gmail.com. So that's it for today. Bye everyone. Take care. And if you have any doubt, always comment down there. Post your doubts and I'll be there to solve it. Thank you. Have a great day.